All right, so one of the biggest questions that we have is what exactly is voice over IP? And for lack of a better phrase, it is exactly as it sounds. It is sending your voice over the internet. But that is a vast oversimplification, of course. What does this really mean? It is nothing less than changing everything about how we handle voice communications. So we're talking about different networks here. We're talking about different protocols, different techniques, different equipment. Everything is different, different skill sets. The only thing that is the same is that we are still going to take our voice. Our voice doesn't change very much. We're still going to send it to somebody else, and that someone has to be able to understand it and then communicate back to us. But other than that, other than those ideas, everything is different. So let's do a quick side-by-side comparison. When we talk about traditional telephony, a lot of terms pop up here, and we have a whole other set of discussions on traditional telephony. But we talk about things like circuit switching and local loop and tip and ring and POTS, and the fact that it's the public switch telephone network, or PSTN. The protocols or the architecture that governs this particular network is signaling system 7, and almost all of the protocols that we're dealing with here are ITU-T protocols. This is as opposed to voice over IP, which uses packet switching. Remember that we're dealing with IP packets here. The protocol suite that we're talking about here is TCP/IP. The protocols themselves, or at least the most common ones that we're going to deal with, are going to be SIP, H.323, Skinny, RTP. Now a little word on H.323, that's still an ITU-T standard. If we follow the voice over IP conversation a little farther, we get into something called unified communications, and that's where we integrate messaging and email and presence and all those sorts of things. We'll talk about those later on. One of the other big deals about voice over IP is that generally it has a lower total cost of ownership, although there are some gotchas there, and we'll talk about that too. We have E911 as a big issue. And of course, instead of being on the PSTN, we are dealing with the internet. Now, as a little side note, remember that many of the companies that are involved in the PSTN are also involved in running connections and traffic on the internet. So here's another way of looking at the two networks, comparing them side by side. The top one here is the traditional telephony network, and we start with a telephone, and that goes to our PBX, or our central office, the telephone switch. And that connection, all the way going down to the phone, that's what we might call our local loop. It also might be a connection to a desktop unit. And these are typically analog and digital. Remember that when we're talking about traditional telephony, we're really talking about analog and digital connections. PBXs, central offices, all have a collection of technologies they use to interconnect. Probably one of the most popular is the T1. And again, this is all governed by SS7. In the lower picture, we can see that the topology looks very similar, although, of course, that's just the way I drew it. But if you take a close look at what's going on here, we see that the voice over IP phone is actually connected to an Ethernet switch. In fact, they're sometimes called Ethernet phones. Taking the place of the traditional PBX is something called a call server, although it is often referred to as a voice over IP PBX. And then, of course, all of the connection types are run by the protocol suite of TCP/IP. Now, I just want to note here that while we're separating many of the ideas, there's nothing at all that says they can't be combined. So, for example, a PBX might service analog, digital, and voice over IP phones. A company might have a TCP/IP based connection going to the internet and run that over a T1. So this is not to be interpreted as being exclusively one side or the other. A lot of the technologies mix and match. But there is one thing that's absolutely different, is that when we're dealing with VoIP, we're dealing with TCP/IP. And when we're dealing with traditional telecom, we're dealing with a public switch telephone network, ITU-T protocols, and signaling system 7. Well, if we're going to start talking about a voice over IP network, we have to become conversant with some of the terminology. So the call server, that is the thing that all of the nodes or the phones register with. So You log in, it connects to the call server. When you want to dial a phone number, you're typically talking to a call server. When you want to talk off-site, you're talking to a call server. The signaling protocol, the thing that allows you to talk to the call server, the thing that allows you to dial numbers, register, make requests, that's the signaling protocol. Now there's a corresponding signaling protocol in SS7 too. When we actually start talking and we're taking our voice samples and putting them inside packets, for that we use the transport protocol. Now a voice over IP network is not a network that has its own set of protocols and that's it. There's a lot of support that goes into this. DHCP and TFTP and power over Ethernet are very common techniques that we use to keep a voice over IP network up and running. Now I've got gateways down here. Gateways have a connotation in the networking world. In this case, what we're talking about is something that understands how to talk to another type of voice over IP network or the traditional network. So it's very common for a gateway to understand TCP/IP and the voice over IP protocols on one side and then understand signaling system 7 on the other. So what I want to get across here is that while voice over IP does have its own equipment, its own protocols, it is really based on the same network that we are used to using for everything else. So we have Ethernet, we have IP, we have TCP, we have UDP. So all of those processes still need to be in place. We also need support from the infrastructure. So on this list you can see DHCP and TFTP. These are basic features of every network. Well, maybe not so much TFTP, but certainly DHCP. Now the guy that controls this whole thing for our voice over IP infrastructure is the call server. Phones, when they come up, talk to the call server, they register, and they also use the call server to make phone calls. One of the other features of a voice over IP network, at least one that becomes very important, is the power over Ethernet. Modern switches today provide power to many, many devices. Access points are another example. But phones need power over Ethernet. Actually, well, they don't need it, but we certainly prefer that they use power over Ethernet, so we don't have to worry about power adapters and all kinds of things like that. So let's talk about some basic operation here. So this is going to be true of most voice over IP infrastructures. What happens first, I sort of rearrange things a little bit here so we can kind of get them in order. But when you plug in a VoIP phone, the first thing that's going to happen is that there's going to be a power over Ethernet negotiation. And so the switch will begin supplying power on the pins that are not being used by Ethernet. So that's 4, 5, 7, and 8. After the phone comes up and starts powering up, it's going to go through its boot process. And among other things, it's going to load its operating system. And then eventually it'll ask for an IP address. Now it's very common for phones also to determine whether or not they have the latest and greatest software. So they go out and they'll reach out and touch a TFTP server, and then if they need to, they'll download configurations or changes to the BIOS, things like that. Now once a phone call is being made, in order to make a phone call, the first thing you need to do is register with that call server. So a phone will come out to the call server and say, here I am. Sometimes users will log in with a password, but the phone registers with the call server. So the call server knows what phones it's supposed to control. Sometimes there's an access control, sometimes there's security, and then there's also the idea of the call server getting in there to help phones reach their destinations. Once a call is made, again via the signaling protocol, the phones will actually start sending voice samples back and forth. And to do this, we actually use the transport protocol. And then finally, when we're all done with our call, we will drop back into our signaling protocol again, and that's just to terminate the call. So let's talk a little bit more about the signaling protocol and the transport protocol here. I may have mentioned previously that the signaling protocols that we're concerned with today are H.323, SIP, and Skinny. Now we will have videos on all three of these, and of course each one of them has a chapter devoted to it. But just for right now, we should know that there are three major signaling protocols out there. There are other proprietary ones and others that are beyond this, but these are the big ones, with Skinny also being proprietary from Cisco. H.323 is a little older. It's very complex. So the world is really going to SIP. We're adopting SIP. Now, I mentioned that the call server is the big dog in the middle of all this, and all of these communications between phones and the call servers occur using this signaling protocol. And when you want to make a call, you also use the signaling protocol. Now, when phones actually make a call, right, they'll go up to the call server, say, I want to call this destination, and then it gets made. And then there's one of two architectures that'll happen. Once that occurs, once the destination is actually ringing and then we pick up, we actually start sending those voice packets back and forth. Now, RTP, or real-time protocol, that's the protocol that we're going to use to make that happen. There's a significant difference between RTP and our signaling protocols. And again, hey, guess what? We've got a chapter on RTP as well. But there's a fundamental difference between them. Now, we have two architectures for handling this. The phones can actually send these back and forth directly, or they can send them up to the call server and then back down. RTCP is the control protocol associated with RTP, and we can use that to track performance and quality. When we hang up, we go right back to that signaling protocol again. And again, with messages going back and forth between the call server and the endpoints, and sometimes between the endpoints themselves. Now, I thought it might be kind of fun for you guys to be able to take a look at what a conversation looks like in terms of the packets. Now, what we've got here on the left is an H.323 conversation, and on the right we have a Cisco Skinny conversation. These have a similar architecture, and if you take a look, I hope you can read these, we can see that at the top we've got DHCP, followed by TFTP, and then we drop into the signaling protocol, and again, H.323 on the left and Skinny on the right. Now, just so you're not get fooled, H.225 is actually part of the H.323 suite. And then we've got a call in there, and I cut out some of the packets, but there we see the call. It's RTP, and then we drop into the signaling protocol again when we terminate the call. So there you have it. That's what you're actually going to see. And as you work through the examples in the book, or you might be doing them in lab as an assignment, this is the kind of thing that we're looking for. And understanding this flow can be important for setup, for troubleshooting, for quality service, and for security. Now, VoIP has a lot of issues associated with it. We've got quality of service, we've got security, we've got the infrastructure, we've just got, getting the doggone thing up and running, getting systems to talk to each other. So there's a tremendous amount that goes into successfully running a VoIP infrastructure. But today we talk less about voice over IP and more about unified communications. Now, we always like to start with voice over IP because unified communication systems have voice over IP at the center of their whole thing. So we sometimes say that the heart of unified communications is actually voice over IP. But unified communications is sold with a completely different idea in mind. So we think about voice over IP, we think about saving money. When we think about unified communications, we think about things like productivity. And so some of the buzzwords are collaboration, shared workspaces, and then, of course, we have all of the other forms of messaging that we're trying to get integrated with our voice over IP system. So the idea is no matter how you communicate, we're going to use this centralized sort of infrastructure to get this all to work together. Another really big idea is presence. Where are you? Can you be found? Can you identify whether or not you're online, available? Can somebody get to you when they need to? And can you get to other folks when you need them? My friend Emilio Di Lorenzo used to like to say that he would decide how to send a message and you would decide how you're going to pick it up. And certainly there was nothing in there that said those two things had to be the same. In fact, you had a wide variety on both ends, the sender and the receiver.